Let me explain 4 bits parallel adder. As you can see, there are 4 full adders, and each full adder adds 2 bits of input along with the carry. So here I have taken an example 1101 A is 1101, B is 0110. So we have A of 0 till A of 3, B of 0 till B of 3. So two inputs signals A and B both are being 4 bits each. That means both A and B are vector represented. That means one signal 4 bits. So that is what vector representation of data type means. So A and B both are 4 bits. A happens to be 1101, B happens to be 0110. That is 0th position to position number 3. So input carry, that is Cin, will be 0 in the beginning. So there is no input of carry in the beginning. Then Cout, that is the carry coming out of the last bit. So I have declared C of 0 till C of 4. C of 0 is nothing but Cin. C of 4 is nothing but Cout. Now A of 0 is added with B of 0 along with C of 0. What you get is sum of 0. Likewise, so the carry that comes out from the first bit addition is C of 1. So when sum of 0 is generated, that is A of 0, B of 0 is added to get sum of 0, you are getting C of 1. That means one position ahead for the carry, one position behind for the sum. Now A of 1, B of 1 is added to get sum of 1, whereas C of 2 is generated. C of 2 is considered for the addition of the next bit. C of 2, A of 2, B of 2 added to get sum of 2, whereas C of 3 is generated. For the last bit, A of 3, B of 3, C of 3 are added to get sum of 3 and also C of 4. Now let us see in this example what is the addition and carry. 1 plus 0 is 1. There is no carry. So C of 1 is 0. When 1 was added with 0, Cin was maintained at 0. That is input carry in the beginning is made 0. So C of 0 will be 0 as well. Now 1 plus 0 is 1. C of 1 is 0. Now C of 1 is added with A of 1 and B of 1. That is 0 plus 1, 1. 1 plus 1 is 0. Then carry ahead is 1. So C of 2 is 1. Sum of 1 is 0. Here C of 2 is added with A of 2, that is 1 plus 0, that is 1. 1 plus 1 is 0, that is sum of 2 is 0. C of 3 is 1. So C of 3 is added with A of 3 and B of 3. 1 plus 1 is 0, carry is 1. So 0 plus 0 is 0. Because carry is 1, C of 4 is 1. So C of 4 is attached to Cout finally to get 1. So the answer is 001 along with the carry bit being 1. So that is how two 4-bit numbers A and B are added using 4 full adders for each bit. So diagram represents C of 0 added with A of 0 and B of 0 to get sum of 0 as well as C of 1. Whereas A of 1, B of 1 added with C of 1 to get sum of 1 as well as C of 2. C of 2 is added with A of 2, B of 2 to get sum of 2, also the C of 3. C of 3 is added with A of 3 and B of 3 to get sum of 3 and also C of 4. C of 4 is made as Cout. Now let us see the program here. Module. So module declaration represents outside interfacing ports. I have given name as parallel adder to this module. Input A and B are 4-bit each. Cin is 1 bit. Sum that is generated will be 4-bit, that is output. C out is a single bit, so output. C, which are intermediate values here, I have declared within the module declaration itself. C of 0 till C of 4. C of 0 is nothing but C in. C of 4 is nothing but C out, what we represent in the program. So output 4 down to 0 is C. Now, whatever the outputs are, we have to call them as register. Some 4 bit are register, C out is register, and C 5 bit 4 down to 0 is also a register. Here, one more variable is introduced as integer, that is I, because we are going to use for loop to represent 4 bit addition. So we are running full adder using for loop 4 times to add 4 bits. Now, as it is in behavioral modeling, we go for always. What is always? Always is a keyword that represents a block of statements which are sequential in nature. At is an operator which will allow the always block to execute every time there is an event occurring in the inputs like A, B, C. Event occurring means change that takes place in of the inputs, then always will be executed every time. So begin is always begin. In the beginning, C of 0 is made C in. C of 0 is made C in. So I am going to maintain C in input as 0. Naturally, C of 0 will also be 0. I am running for loop now. I being 0 up till I less than or equal to 3. Every time I will be I plus 1. That means I value grows from 0 to 3. So 0 to 3, that means 4 times these two statements are going to execute under for loop. Begin of for loop here. Sum of 0 is equal to A of 0 XOR B of 0 XOR C of 0. That means in the first full adder, 0th position bits are added. Next, I becomes 1, sum of 1, A of 1 XOR B of 1 XOR C of 1, like that. Up to sum of 3 is equal to A of 3 XOR B of 3 XOR C of 3. That means all the full adder, each one of them execute uh, for adding 3 bits. So that 4 full adders are added to used to get addition of 4 bits. Now, I position is ahead here, I plus 1. C position is ahead, I plus 1. That is because when a sum of 0 is generated, you are actually generating C of 1. When you are generating sum of 1, you are generating C of 2. So when sum of 0 is generated, C of 0 plus 1, that is 1 will be generated. When sum of 1 is generated, then C 1 plus 1, 2 is generated. That is sum of 0, C of 1. Sum of 1, C of 2. Like that, one position ahead, C is generated. Here end for the for loop after running of these two statements 4 times. C out is equal to C of 4. That is the last sum that generates the carry is C of 4. Whatever the value that you get as C of 4 is pasted to C out. So end is for the always here. Then end module is the end of the entire module or the description. Thank you.